Okay, so this is the pretest that we will be working on for the function unit. And here is question number 1. Just get that working. Here we go. Okay, so when they're asking you to find the domain of a rational function, basically all you have to do is set the denominator equal to 0, factor the denominator, using a -7 and a +2, set each one of those factors equal to 0, and solve them independently. The two answers that you end up getting are the only values that you're not allowed to have in the domain. So your domain is all real numbers except for -2 and +7. And that is the way you write your domain for the first question. When it comes to question number 2, anytime you have a radical expression, you have to take the part underneath the radical and guarantee that it's positive. The way that you guarantee, I probably shouldn't have said it like that, guarantee that it's not negative, because you can't take the square root of a negative number, which means the expression that's underneath has to be greater than or equal to 0. And when you solve this, you move the 3 to the other side. But remember the rule, when you divide by a negative, and I'm going to divide by a -1, you flip the direction of the inequality. That answer is actually the domain. You can only pick x values that are less than or equal to 3. So when I write it down in interval notation, numbers that are less than or equal to 3 start at -infinity and go all the way up to 3, and because it could be equal to, you can actually use the hard bracket. And that takes care of the domain for the first 2 problems. Okay, the next 2 problems on this page. My first one has a radical in the denominator. Now you know the rule is you're not allowed to have a negative number underneath the radical. So normally we would say that that expression must not be negative, so it's got to be greater than or equal to 0. The only issue we have is you can't have 0 in a denominator, so you have to erase the or equal to part. Now, nobody solves quadratic inequalities. Everyone actually changes this into an equation. So you have x squared minus 1 is equal to 0, which you can use dots. So it's x plus 1 times x minus 1 is equal to 0. And when you set each one of those factors equal to 0, you get 2 answers. One of those answers is -1, and the other answer is +1. Now remember, you were never asked to solve the purple problem, you were asked to solve the green one. And all inequalities get solved on a number line. The numbers in purple that you had gotten go on that number line, -1 and +1. But because my inequality is just greater than, they both get open circles on top. And the rule I gave you is if they use greater than, and that's what they use, you always shade on the outside. So numbers that are more than 1 work, and numbers that are actually less than -1 also work. So the way you're going to write down your answer in interval notation, because there are two separate shaded in sections for this, your domain goes from -infinity to -1, but the -1 is not included. And then you have a gap, so you put this union symbol in the middle for the gap, and then you have numbers that are greater than the number 1, but remember, it's kind of like you're almost at 1, and it goes all the way out to infinity. And that's your domain for letter C. Okay, when you get to the next question, we are looking at a logarithmic function. And you have to remember that the inner part of a logarithmic function must be positive. And if it must be positive, you're writing down that x squared minus 4x has to be greater than 0. Can't even be equal to 0. Once again, nobody solves quadratic inequalities. We're actually going to change this into, maybe this color's, I used that one already, an equation. So when you change it into an equation, you get x squared minus 4x equals 0. And you factor this using a GCF. Take out the x, you're left with x minus 4. Set each one of those factors equal to 0. And then solve each one of them. On the left, the answer is just x is 0. But on the right, the answer is x is equal to positive 4. Now remember, you were not asked to solve the red problem. You were actually asked to solve the pink one. I think I chose that color. So basically, you're going to draw a number line to solve it, because it was an inequality. The numbers in red that you are putting on are 0 and 4. My inequality is just greater than, so it's open circles above each of them. And greater than means to shade on the outsides. So all numbers that are greater than 4 work, and all numbers that are less than 0 also work. So the way you write down your domain for this one, because it's two separate sections, is your domain goes from -infinity to 0, but you're not actually using 0. And then there's that gap in the middle, and then it starts at almost 4 to infinity. And that takes care of the first page.